feel free to share how you know about API6, if you are using API6 or if you are looking to contribute to API6, or you're just trying to figure out what API6 is about. Like, feel free to mention that as well, so we can all get to know each other better. And if you go to the and while we wait, let's look at some of these resources. So if you go to the meeting minutes, you will find resources on how you can get started with API6, how you can contribute to API6, and also uh, uh, upcoming events that we have planned around the world, which is related to API6. You can also find the social media channels here. All right, so we are already 3 minutes in. So without further ado, let's get started. So welcome everyone to the Apache APISIX community meeting minutes. We are trying to have this meeting once every month, but based on how your interest and like how this meeting is going, we can probably make it twice a month in the future. But like for now, it is once a month. So I'm Navendu. I'm a contributor to Apache APISIX, and we have a couple of folks on this call. We have also had a couple of speakers today. So without further ado, Bobur, would you like to give us some news from the API6 verse?
Yes, hi Navendu, hi everyone. Thank you for giving me this chance. Let me share my screen in this case, and then we can get started. So just a moment. So we can start. I'm super happy to be here in our next global community meeting with Apache APISIX. And we missed one in September, I guess, because I think in October we missed one because we didn't have many people attended. Like now I see we have enough people are attending. So thank you, first of all, for joining this event because I believe it helps for many of us to at least to know each other in this meeting and at least to say hello and to get to know who is using APISIX and how we are supporting each other. Also, maybe get some answers your questions in the real time. So feel free to stop any of us if you have any questions today. I'm also happy to provide for you some recent updates with Apache APISIX, what we achieved so far, how we are growing fast, etc. So, and then we can take other speakers on board. Maybe many of you already know of me. My name is Bobur. I'm a developer advocate. If you would like to keep in touch, here's my social channels. Feel free to ask any questions and ping me if you need any help around APISIX. If I don't know how to answer, I know who can answer and who can make you help better. I can redirect to a responsible person. And we have our speakers as Navendu started first, and then next speakers we have after me, Wey Gu, welcome. He's a developer advocate for NebulaGraph. He's going to present today a very interesting topic based on his real experiences, how he had successful integration with Apache APISIX, and he would like to talk about what other complexity he solved and what he achieved at the end during his presentation. So before we jumping into that point, let's go through quickly what are the community updates we have today. Here's a short agenda from my side. Like as we do usually, like I'm gonna explain the purpose of this meeting shortly, and we'll have a look at Apache APISIX now. And I will talk about some of our recent successful student workshop stories, because we are also hosting some student workshops to teach and help the students to skill up, not only in the Apache APISIX project in general, like API Gateway, etc., so that they can already start contributing as a student to open source projects. The main purpose of this meeting is bring to all our users and contributors together in one chat and share monthly our statistic information, right? And also we can work together, participate in building the future of Apache APISIX. So here, as you can see from these recent numbers I got from our community metrics, it's publicly available. I'm going to also put in chat the direct link. You can check like how we are growing on the number of downloads of Apache APISIX from Docker Hub. Like it's almost reaching 5 million. And also you can see the graph on the screen, like the green, I think the blue one is Apache APISIX is growing very fast compared to other open source providers we have right in our list. And next one is good celebration is our Slack users have reached I think 1.1K. It's growing very fast. If you look at the history in February, in the same year, we had like around 240 Slack members. Now we have like how to triplet, maybe more than triplet. And our community members, they are very active, especially on Slack. They're asking questions and helping to each other. It's good to see it. That open source community project is growing. And here is, as you can see, some of our posting channels also growing very fast. I did small picture of what we did, our posting channels, how many people viewed, read it, our blog posts. We got around 27K views in September and October. Around like 155 new followers joined on Dev2, Hashnot, Medium. It's extra to our own blog on Apache APISIX, right? It means our blogs are very liked from the community because we are not only talking about you need to use and you need to use only Apache APISIX, but we are also providing some technical descriptions and the ways of how they can solve their technical problems by using some kind of ready to use some open source projects. Please, if you are not following up our the channels, posting channels, you can check it on Dev2 or Medium or Hashnot. You can get some updates because we are posting 5 at least new articles every month. They are quite famous now. And then also we got some channels, YouTube channel statistics, let's say, we are growing like increasingly in 30% in this month. People like to watch YouTube. I mean, mainly myself also contributing to record some videos, but everyone is actually open to contribute. If you have something to share with people, I'm happy to also publish on YouTube, or if you're presenting at the event, anything about your technical topics, not only related to Apache APISIX. If you have something technical, we will have a dedicated list on YouTube, and we can publish also these technical topics because it's highly appreciated by the community to learn something from each other. So we got like 45 new subscribers increase this month. I mean, in November and October also in the middle. And one thing I would like to bring your attention is some users that myself, I didn't know that like Zoom has been using the Apache APISIX for a long time that I found. If you don't know Zoom, like we're also using some of the meetings, like it's nowadays becoming a very popular online teaching and social meeting the environment. And for example, Apache APISIX Ingress controller plays a very important role in Zoom's continuous delivery pipeline. Like they're using in this their CI/CD pipeline to make a proper the routing to the releases of new versions of Zooms by using Apache APISIX Ingress control. It's one of the examples like of our famous users. And next one is I also surprised to know the Tencent Cloud also using Apache APISIX, I think, for more than a year, if I don't mistake. And they have different projects. Of course, it's a famous cloud, very reliable, high performance. And at the same time, they are using Apache APISIX, not only one team, but more than 10 teams. What I like, Tencent teams are still maintaining Apache APISIX features. for Tencent and keeping cooperating with us, with Apache APISIX community to introduce now some new features, helping out and improve our existing plugins, etc. Or next one, for example, AirWallex, the global fintech company, they also built their financial platform with the payment networking. I mean, they also support like 50, I think, currencies in, I think, over 130 countries. They're also using Apache APISIX to make an intelligent routing solution between the microservices. And Apache APISIX Gateway decides actually where this transaction of data should go and how it should be processed. This is a cool thing. And next, for example, this WPS, like writer representation spreadsheet, is very famous in China, especially on the domestic office software producer. They are, for example, providing some extensions for, let's say, Microsoft Office programs, like that you can use these services for free. Also, Apache APISIX handles their tens of billions API calls like per day. It's, I think, a query per second nowadays, excluding 1.2 million. This is also fantastic kind of statistics, how is Apache APISIX scalable and making a quite good performance for the real projects. So next is Trendyol, is our current new user. Trendyol is an e-commerce platform, online platform in Turkey. They're also using some of the APISIX features, and also their engineering team contributing to new plugin development. Then finally, last one but not least, is many of you already heard that this FIFA World Cup Qatar this year already started, and also we had this integration with CCTV, Chinese television, for online streaming. So all the people who are based in Asia, they are now watching online games match, I mean, with a high quality, because Apache APISIX doing this streaming for this World Cup. So this is one thing, and from the conference side, we are not only writing a blog post, also we are giving some talks. Let's say here's the statistics, like we attended, or we are planning to attend by the end of this year, 85 conferences. It means it's quite a lot in 22 countries, like such as United States, Canada, main part of Europe, Central and Eastern. Also in India, in China, we already have lots of conferences. We are not counting it; they are mostly the global that we are having. And we are also having at least 15 workshops per month with the universities and maybe some community organizations in India and in many other countries. Here also some of the, you can see the feedback, what we get from this workshop talks. Like students are happy, at least they are getting one or more news or knowledge after we make this workshop. So and some more real great feedbacks from attendees, from students and from university departments. And here's a picture from our last one of the workshop for students. There was a quite big amount of students joined. I think it's from Pakistan. We had lots of contributions. So with that, I'm just sharing this information shortly, like how we are growing on different channels, like GitHubs, like, and we have also Instagram. If you don't know that, please, if you're using Instagram, you can join to share or to see some pictures with our community. And some of the learning channels. If you are missing, just check these learning channels once again. With that, I think I am done. So I can hand over the presentation to Navendu back. Thank you.
It's thanks, Bobur. So we have Wey Gu, who will be talking about APISIX and NebulaGraph, and will be showing us a demo. So I invite you to give your demo. You can share your screen.
Yeah.
Okay. How about now?
Good.
Yeah, good.
Okay.
Perfect.
Okay. Sorry for this network is page. Okay. So I am Wei from China, Shanghai, and I am an open source lover. And in daytime, I'm working on the NebulaGraph community, and I used to work on OpenStack community years before. So you can find me in GitHub with this handle and Twitter. And this is my blog. I post something around mostly graph tech, but sometimes I write something around cloud native. So today I will share something around NebulaGraph and how it looks like, and I will share how we leverage APISIX to address a couple of our pain points in our project. And finally, I want to share you some interesting use cases around NebulaGraph, which is the graph database, in case you are not quite familiar with it. So I will begin with the what is the graph, but I believe now it's not that strange to most of us, because graph database and the graph-based technologies is becoming more and more popular. So the graph thing is referring to it's a mathematical concept, and it was initially brought by a problem called the so-called seven bridge problem. So it's like hundreds of years before. There is a city in Europe, and we have two rivers here, and it cuts the land in a couple of different pieces, and we have seven bridges here. So one of the people raised this question that is this possible for us to traverse all the bridge to go through all the land in the city without walk on same edge twice. So, and the answer is no, it's not possible, and it's a mathematical problem in the graph or topology. So if we want to abstract this problem and trying to solve it, so we can draw this picture into something like this, and this is the island in the middle. And finally introduce. So this is actually the simplest concept of the graph thing. So in this graph, we only care about the node or vertex and the relationship or the bridge between them. So this is all graph is all about. So why do we even need it? So I want to start with this. Oops, what happened? Oh, sorry, I need to because I turned off my VPN, so I cannot give this slide. So this is the slide surfing the Google. So Google bring the graph technology to the search engine domain like 10 or more years before. So with that, we can do something more than maybe I can demo you with another alternative. So for example, we can try to think. So we want to check MCU. So you will see something. So this is based on the traditional search result, but there are some cards here. So these are actually, instead of searching based, it's actually knowledge based. So underneath, the knowledge were actually, structured in a graph way. For example, if we want to know Yao name, why, so we want to search something like this. So you cannot actually seek this information from pages. Oh, this is wrong. If you are using Google, you will know the right answer. So this is not knowledge based, but if you search it in Google, you will know it's knowledge based question answer. And underneath, the graph technology is powering this and making that possible. Sorry for that. So we have some concept on what is graph. So what is graph database? So graph database is a database that's use the graph structures to store persist data, and in the meantime to query the data in a semantic that's designed for graph, or we say nodes and edges. So why do we need such thing? Why can't we just use a KV or a document or a relational database? So the question is quite straightforward, because if you your system heavily relies on such pattern of traffic that's related to the graph thing, maybe your general purpose database cannot fulfill your question. Just like you need an API gateway in certain cases, so you cannot use your traditional HA proxy or traditional reverse proxy. You cannot do it. It will be quite painful when you require such need massively. So similar to graph database. So one of the reasons, if I summarize it, is a schema thing. So this is quite small. I'm sorry for that, but you just think you want to persist the graph data, like this in a tabular relational database. So that will be something like this. So every edge here will be reflected in as a join between two tables. Sometimes you want to create an intermediate table between two tables. So that is quite not that straightforward. And another part is around the semantic. If we want to do some graph query, it refers to, I want to jump from this type of point to another point and then to another point, like 3 hoops jumps. This is a typical graph traversal. If you want to do that in graph database, you will write queries, something like this. So I'm not going to dive into the specific queries, but it's quite similar, quite straightforward. But in other side, if you want to use the circle, it will be a join curse. It will be a disaster. You want to do the multiple hoop queries. And finally, is the key point deal maker is the performance. So with graph database, you can do the graph query in the high throughput on the large scale of data in a quite small latency. But when it comes to circle traditional database, sometimes your service just cannot be response in real time. So sometimes you just wait forever, or like you cannot do it in real time. You have to wait for a couple of hours. So this is the deal maker for most of our users. I always want to demonstrate this in some of the memes I create. So it's not that great, but I like the metaphor. So this is around the query language itself. So oops. Or maybe I need to just a second. My video is on. Sorry. How can I move this? Okay. Wait, a refresh. Okay. Cool. Okay. So this is a old retro video game called Snowball Brother. So in this game, we want to control this snow brother, to throw the snowball to kill those monsters. And to do that, we need to jump from one stage to another. So I want to make this metaphor that we are doing some graph traversals in the tabular database, something like this. So every time you want to jump to another monster, you have to jump to another table and scan from the from the front. And another jump is it's like a join in traditional or tabular databases. So in that sense, it's relatively expensive, especially when you have a bunch of jumps and your data scale is quite heavy. So the difference between the traditional database and you can create index, like when it comes to the game, when you're creating an index, you accelerate your scan of the data, but still you need to scan it. Just like you have a fast lag thing here, just like this, you have a faster lag, but still you have to scan data. But when it comes to graph database, it's just like you have this green bottle, so you can fly. So you can directly fly from this point to this point. And in graph database, that traversal is just O1 cost in time complexity. So that is, it's an improper metaphor, but I hope to make some sense of how graph database can help in the graph query case. Why it's fast. So, but then I want to give a brief introduction on why we create. There are already some, graph databases out there. Why we create yet another one? So, so it's related to NebulaGraph. So one of the reasons or the most answers from our community users is about the performance and how NebulaGraph can scale in the high large scale of data. So NebulaGraph was designed from day zero distributed. So it's designed for the large scale of data. So this is a picture from Britain, I guess. They have this shape blocking in the river. So two of the guys pushing it forward to make everything work again. But similar questions can be found. This is a picture from the Zeus river. So if you can recall, this huge shape was blocking there the whole world shaping for a couple of months. So the point is even in a similar situation or scenario, the scale matters. So if you want to solve things in a different scale, you have to design a whole different solution. And NebulaGraph was designed for the large scale, hyperscale data. So I call this data from so this is from the Tencent Cloud, also the user from APISX. And this is from Meituan, another company in China, is similar to the Yelp. So from their benchmark is showing that when the data becomes large, so NebulaGraph excels. And so this is a brief introduction on why underneath NebulaGraph can do so. So NebulaGraph was designed similar to the CRDB or Google Spanner. So it's a share nothing architecture, but I'm not going to dive deep here. I just point something is the computation layer is stateless, and the underneath storage layer is separated from the computation layer and share nothing. And on the storage layer, we are using Raft, and we sharding data automatically, so user don't have to deal with how data was placed or sharded. And underneath is Raft. Yes, another reason that a lot of users join our community is we are relatively active and healthy community already. So we started the project in 2018, and we have our very first production user in December of 2019. And we have a bunch of users in the community, and they contribute back a lot of cool new features. And we have 1.0 into 2020 and 3.0 in the beginning of this year. So if you're interested, just check out this URL to see more. Yeah, I'll give a brief introduction of the graph query language. So we support NGQL, which is the in-house preparatory. We designed it from scratch. It's a lovely query language, and we also support the de facto OpenCipher query language. So there will be a ISO GCO standard drafted very soon, and we will be the first teams that support this language very soon too. And we have a relatively rich ecosystem and a bunch of different surrounding projects. So NebulaGraph is open source under license Apache 2.0, and most of our surrounding projects and tool chains are also open source in this license. So we have a bunch of Kubernetes operators and observation and deployment cloud related projects also open source, and something around the big data, the graph computation, and the connector to different open other data sources, a bunch of them, and a bunch of clients, etc. So, and I'm not, so the time is quite limited. I'm not to dive into most of them, just to give you some of quite glance. So Studio is a graph visualization tool, so you can guide you can manage the graph data and explore the graph data in your web browser. It's also open source. So sometimes you want to write quite long queries. So we have the graph explorer. So with that, you can create queries virtually. So which is a fancy feature. So if this is another product in our community, so you can drag and drop and create the complex graph queries in this way. We have a lot of different other fancy features for Explorer. For example, this one, you can render it in 3D. Another feature is you can see how the data flows in this graph subgraph. It's a quite interesting feature. I will show you how this reflects to our real life use cases later. So this is the graph computation orchestration platform. You can create the graph algorithms in a no-code way. So I'm now to dive into, and you can even create a pipe graph jobs in the Graph Explorer. And you can have this dashboard thing. So it's basically observation GUI projects. You can monitor everything in this dashboard. And also we are in the cloud native landscape in the graph in the database. So here, this is NebulaGraph. And we have, as I mentioned, we have a graph not Prometheus explorer, related, quite mature cloud native thing. And we are actually also on the Azure, GCP, and AWS. We have a bunch of different importing toolings. I'm not going to dive into everything around that. Sorry, this is the network thing. This was not displayed. This is Nebula algorithm is about graph algorithms running on top of graph database. For example, you can run the PageRank. It's a quite well-known graph algorithms. You can run it on NebulaGraph as well. So finally, I come to the main topic. I can share you things around how we leverage APISIX to accelerate a couple of different NebulaGraph use cases. So the problem, I'm sorry, the page was not rendered properly because of network. I want to address 3 of the major problems The first one is the GraphD load balancing. I didn't dive into the design of architecture of NebulaGraph. So basically, we have 3 types of processes in NebulaGraph database. So in the surface layer is the GraphD graph daemon. So it's the normally in most of cases it's the only interface that we want to expose to the end user. So you want to do the graph query and you want to log into the graph database. You just go through this process. But as I mentioned, our computation layer is stateless, so you can easily scaling your GraphD as your need. You can put, oops, we have the picture rendered. You can have like 10 different GraphD instances. But how do you do the load balancing? So most of our users, and because we implement our own GraphD clients, our own, so we initially encourage our users to do this client-side load balancing. So that means our users have to define all the available GraphD instances in their code of the client side. That's totally doable, and in our client, there is a mechanism to at least you can do round robin thing to select the available the GraphD instances, but that's not quite elegant because the users has to hard code or handle this service discovery and load balancing in their application code together, bind it with the client side. So we can instead leveraging the API gateway, for example, API 6. So with API 6, we can combine and discover all available graph daemons and expose only one instance of the GraphD to the client side. So there will be no code changes or no client side restarts involved, and everything is elegantly managed by API 6. And on top of that, we can leverage all the control plane advanced features in this modern API gateway from API 6. So that's one thing. Another thing is around the security, the TLS. So for the consideration on the security and the compliance, most of us will make the connection between your application and the database connection secure with the TLS. NebulaGraph comes with the because the connection between the client and the GraphD is actually Apache Thrift. It's an RPC protocol based on TCP. So we provide our native TCP capabilities to user, but frankly, it's not that easy. The GraphD is a computation layer. So if you want to manage the TLS layer, it's quite heavy, and every time you want to maintain you want to refresh your TLS thing, your certificate and CA, you have to restart the GraphD. So, and the files that we want to set up the TLS connection between your processing NebulaGraph to the clients is related to our configurations. But when it comes to configuration change in NebulaGraph, the process reload is needed. So that make the coupling of the TLS and our NebulaGraph core isn't that user friendly and not that easier for the engineering and the maintenance. So ideally, we can make this decoupled with the both the application and the graph database core. So that's where we want to introduce the API gateway like API 6. And it has the management API and the dashboard of APISIX is quite lovely. So we can make the certificate thing fully managed by APISIX, and we make the TLS termination step there on the APISIX. Another benefit we get from this, we put this layer to APISIX is previously, if we want to enable TLS on NebulaGraph, we have to enable every connection, not only the GraphD, but also the storage-D and the meta-D. So these are the two other processes inside of the NebulaGraph cluster. So if we want to enable TLS, we have to enable every traffic between them. But on the perspective of the NebulaGraph cluster, it's actually the west-east connection, and sometimes we don't want to, it's quite latency sensitive. If we want to bring the TLS outside of the cluster, but we don't have a choice. We have to enable the east-west traffic also with the TLS. It's quite expensive as well. So with the NebulaGraph, with TLS terminated by the APISIX, so everything was solved. And the third problem is the most interesting one. So that is we want to especially when we want to put a NebulaGraph in a cloud native this deployment. We have some specific problems when we want to expose our underneath endpoints, the GraphD. So this is actually related to how NebulaGraph was designed. I didn't mention before, but we have three types of processes, which is GraphD, the meta-D, and the storage-D. So as I mentioned, in most cases, we just want to talk to the GraphD, and that's why by default, we just expose the GraphD layer, and also GraphD is stateless. So it will be quite easy to, load balance and make the traffic going through. But underneath, unfortunately, our GraphD is stateful. That means every single instance of GraphD is different. So, but there is such case. It's not that common, but there are still such case that we want to, for example, we want to compute the whole graph. We want to fetch and scan the whole graph data to some memory, some large memory system, and want to do some full graph computation. So in that case, we have the capability because we are separate the computation layer and the storage layer, and we have the capability to bypass this GraphD and to let the the other workload to directly talk to our storage layer, which is good for our design. But the problem is if we want to scan the data from the storage D, because the storage D can be scale in and scale out, so it's actually a list of instances that will change dynamically. So in our design, we have to fetch the list of storage instances from the meta service, but the meta service was maintaining, so this is a service discover thing in self-contained of Nebula cluster. So in this case, all the service instances of the storage D are only exposing the address of the inside of this cluster. So if we want to deploy a NebulaGraph like in Kubernetes, and we want to use our computation layer to scan the whole graph, we have to enable all the storage service accessible outside of the cluster, or sometimes even outside of the Kubernetes cluster, because we don't have strong assumption to put everything in one infrastructure. But that is quite painful for our community users. So previously, before that, our approach was we have to create we have to manually create, it's quite painful, create all the specific storage instances as a service, and we create another Nginx, and we manually configure everything and wear everything, and we create an external DNS to ensure the clients are seeing all the storage instances exactly the same domain name, full qualified domain name and port as it was running inside the cluster. So this is extremely painful for our user and for me myself. So what we can do with API gateway, cloud native modern API gateway with the API 6. So everything is so very, elegant. So underneath, we didn't change anything. We also leveraged the OpenResty or Nginx, the streaming feature. So the magic happens only on the control plane. So with API 6, we can leverage, because the stream proxy, this is the concept in API 6, we can, it's actually just a layer 4 proxy or load balancing feature, forwarding function, but you can, and everything was, the configuration or the meta of this thing was managed in a modern fashion with API 6. So you just and the other thing is this streaming can support SNI. SNI refers to the TLS 1.3. It's actually just the extension hostname of all the upstream nodes. So with the streaming proxy of API 6 plus the SNI functionality, what I can achieve is I just create one single service. I configure the port listened in stream proxy in API 6, and I use the stream. This is the API of API 6. I create the stream route here, so everything is connected, and I'm using API 6 to manage a TLS. So with the TLS introduced, I can do the SNI routing. So that means we can use only one service to enable all the, the underneath different stateful storage exposed outside. So basically, I create this single service, and then I use this. This is the API 6 API. I'm using the stream routes. I create one. So everything can be software defined and automatically connected. With this API, you can discover your storage list, and then dynamically create corresponding stream routes in API 6, and you leverage the API 6 administration API on managing the certificates, the TLS. So everything was properly weird. So this is the this is saying that we want to expose this port on TLS with the on TCP with the TLS enabled. So this is the config map of the API 6. And then finally, actually, I provide an end-to-end experiment on this. I will share it later. And I didn't use the API. I used the lovely API 6 dashboard to manage my certificates. Quite smooth and beautiful. Yeah, and finally, I make this all three problem solved, and I shared this in my blog here. So for now, I'm sorry that this URL is Chinese only because I didn't have time to make the translation. I just composed yesterday, last week, sorry. So I am planning to make an English version later. So you can then, in my blog, you can switch the language to see the whole thing, whole end-to-end solution of how I resolve the three problems with that API 6. Yeah, and finally, I want to make you more sense. And sorry, I assume most of us are not familiar with NebulaGraph yet. So I want to make you more sense of how it can be reflected to our, daily services. So, the first question. So this is a capture from one of our user. It's like a Chinese version of Yelp. So this is a function that underneath of leveraging NebulaGraph. So it's actually a QA knowledge-based QA agent, just like a Siri, but not that smart. So this is a question like, is there any McDonald's nearby street food bar? So underneath, you can do this with the graph database to answer this question. So another thing, this is related to the reasoning or the explanation of our recommendation system. So we all know that recommendation system can be quite complex. So even the author of the system cannot know why we put this result in the rank high. So with NebulaGraph or graph database, we can make everything in the graph and find a path between your user and your suggested candidates. And you can find a reasonable path and make this. For example, you want to answer this, give a hint of this recommended restaurant, like those from Beijing enjoying the Korean cuisine said this restaurant is great. So this is the reasoning of a recommendation system. So there are a bunch of different other use cases, and I love to show you a little bit of them, like social network, risk control, etc. For example, this is a end-to-end runnable version of the knowledge-based QA system, and I implemented an open source it. If you're interested, you can check my blog, and the source code is also on GitHub. And this is the question like, what if I eat food when I have bar symptoms? So think of this as a question on a health agent like Siri, but answer your health questions. And this is a demo of this project I made. I even create a front end for this. Yeah, you can even use your voice to talk to this agent. You ask a question, and then it will query the NebulaGraph and then answer your question. So it's a similar thing. So I want to show you another question. The second question is sorry. Who are my mutual friends? So this question can be a KBQA system, or can also be a social network case. So this is like, who are the friends that are also our friends are also my friends. So we call this a mutual friend. So this is a typical query that will be done in a graph database. So I'm not going to dive into the specific queries, but it makes some sense if you look into a little bit of this query. And in NebulaGraph, we will query this result like this. You can see your friends, also your friends, but also your direct friends. And I am counting the number of the mutual friends. So this one team, Tony Parker was ranked highest. And if we visualize the result, you will see. So this is your starting point, Team Duncan. And you will see that Tony Parker is here. So he has a lot of connections connected with Tony Parker, and those connections are also direct friend with Tony Parker. So this is a typical social network use case. So imagine if I change this match where connection, I can if I ask those my friends, but not my friends. So it's easier to, you just modify, add a not here, you will have that query. So that's a typical use case you will be suggested, like in your Facebook or LinkedIn. So that's a social network use case. And this is the architecture of the this that system I demoed. I call it a theory. And basically, this is the backend side. You just doing the typical QA agent thing. You want to do some semantic processing, and finally you call the graph database here. If you are interested, just feel free to check this repository. Sorry, if you want to fact you can find the repository in this URL as well. Yes, and the recommendation system. So I write a whole a whole blog post on how we can do or create a recommendation system with NebulaGraph here if you're interested. So this is only one of the scenarios that you want to recommend this guy some movies that he may be or she maybe are interested in. So this is one of the approach that you want to go through all the movies he had watched with a higher rate, and you want to find all those movies also rated by other high rated by other users, and you want to find most of them share the most connection here, and I mark them as green. And you want to find all of the green marked users, which we consider they share the similar interests with our candidates, and they're watched movies also with higher rate, but not yet watched by the given user, and then we will recommend those users to this user. So this is a per guy's recommendation system. The real world system will be much more complex, but it makes some sense of how this works internally. And indeed, some users are actually using this approach. And yeah, underlying is just a query in graph query, something like this. So the second part is I want to demonstrate you as I mentioned, we can explain why we suggest you this movie. So here, this is the user ID, and this is the suggested ranking high recommended movie, and we just do a find no loop path from this user and this movie ID over all the connections, bidirection up to 4 steps, and then we return. We can find one of the paths is between the Star Wars, and the reason is the cast of this. He watched this Star Wars, and most of the cast are also shared by this. Of course, by another Star Wars, and also if you watch later, there are some greens like classic, jeans like classic and Academy Award winners. So there are a bunch of different common passes between the two. So you can give a reason to this recommendation. So this is an interesting use case as well. So, and another use case is fraud detection. So fraud detection is like if you have a payment system, you have a fintech system, or you have a UGC system, like everyone can tweet, everyone can post. There still are some, abuse of their accounts. So how can we prevent from to maintain a health system? So this is a fraud detection system. So, for example, this is a graph that's related to the fintech. You want to persist the loan applicant and the related information. This is a loan application. You have you store the phone, their working corporations, their devices when they are doing this application and something like that. You connect everything. So with that, you can do the graph query. For example, this is a query pattern that you want to do it in this graph to know this user was connected to a device that's used to used by a bunch of other users, like hundreds of other users used to use this Wi-Fi ID or similar phone numbers or phone device. So we can, in this pattern, we can mark this transaction or this user as a high risk. So you can potentially prevent the money lost in this fraud transactions. So this is just a simplified example. If you want to know all the patterns, we can leverage graph database or even GNN, the graph neural network. I gave an example end-to-end demo in this blog post if you are interested in. So this is the query and the hood of this, this insight. So another use case is called data lineage or data governance. So this is a system called Mansion. It's another open source project called in Linux Foundation. So maybe the network isn't that flexible. Okay, I'm not going to demo that video. So this use case is like, imagine you have like thousands of tables and a bunch of different data sources in your data lab or data warehouse, and you have a bunch of different services, different pipelines relying on each other on different data. So how you want to make sure you can change the data schema, you can delete this table, you can add new service relying on this table, how you want to make the data maintained and qualified. So you need such system to know the data's lineage. So that's where we can leverage NebulaGraph and something like this. I think we use too much time. I'm not going to demo everything here, but imagine you can do it quite beautifully and elegant with this. And this is the query underneath. So this single query will help you fetch one single table, all the deep related components like other table, other users, other application, other services. You can in this single query, and you can query it like in less than 1 second, like 0.5 seconds to know everything in graph database. So it's a typical use case. And if you are interested in this project, it's called Mansion. This is RFC, and I gave a draft implementation with Mansion with NebulaGraph as the backend. So this is the RFC link. Yeah, maybe this is the final one. Blockchain, of course, we can. The blockchain, the block itself is a graph, and you can model the things here like this. And imagine you want to see what's happening on the blockchain, and also when you have multiple chain, and they can be shared by same wallet or same person under the hood. So how you want to get insights from that? You can do it. Just import it to NebulaGraph, so you can find the relationships, correlations easily. Yes, this is the another use case. I'm sorry, it's not the last one. Sometimes you have a lot of systems, or you just acquire a new company, you have 2 user systems, and or even in one system, how you can know maybe some of the users are under the hood actually one logical users. So with the graph technology, you can do that. This is a query simple query. I want to connect all the users with similar email handle prefix, yet with the address that's geography in the short distance. So I'm yield this distance, and when this distance is smaller than a certain number. So then I found these 2 users are similar. Their address are quite close, and they have a similar email handle. So you can combine it with a lot of different factors and make them connected with the graph technology. So you can you can mapping the users in this way. And I have a blog post in this here as well. Maybe this is the final one, or like you want to know who are actually holding the shareholding of a corporation. You can connect them with NebulaGraph as well. And this is a demo project I created and open source here. So with that, you can easily query how this who are actually control this company. And in one go, you can know underneath a bunch of the other companies are share some hosts, have the whole sharing of this company, and a lot of other users are, as a roles of the company, or share the hosts of the other companies related to this company. So this is a typical use case on the shareholding relationship analysis as well. And I hope, oh yeah, we come to the end. So let's do a quick recap. So we know what is graph. It's all graph, the vertices and the edges between them. And the NebulaGraph is an open source, distributed, cloud native graph database that excels in large scale of data. And it has a relatively rich ecosystem. So APISIX can help three pain points of NebulaGraph. Especially, we can leverage the stream proxy root functionality to enable, when you want to scan, you use your Spark to scan the whole cluster data in NebulaGraph, and you can bypass the GraphD. But if you deploy it in Kubernetes, but your Spark is outside of Kubernetes, how you can do? You don't have to do your hack by your own. You just put APISIX in the cluster, and everything was fixed and permanently maintained in an elegant way. And then finally, I gave you some glance of how graph technology can help our real-world problem. So I hope you enjoy the session, and thank you so much. And it's my privilege to have this time to share you something around open source and NebulaGraph and APISIX. And I guess that's the whole part of my side. Thank you.
Yes, thank you, Wey. Thank you. It was a really informative session. We learned a lot about graph databases, and like it is always interesting to see different use case of APISIX and how APISIX is being used in really diverse situations. Yeah, definitely. Like we as Wey mentioned, he has written a blog post, and he'll also be writing it into English. And probably like we can also also maybe publishing it on the APISIX website, and like I'm sure you'll find it soon in the coming days. So thanks again. I think everyone found the session really helpful. So we are a little bit out of time today, but that's no problem because we had a really interesting session. But we have a small topic left, so I will just share this resource. So last time around we had a lot of new contributors, so we decided to create a small new contributor onboarding guide. So basically this guide will help you um, it'll help you orient yourself with the APISIX and its related projects. So APISIX has a lot of projects across a lot of repositories. So you can check this guide out, and there are also some links you can use to go further and become a contributor to APISIX. So I just share this PDF on the Zoom chat. I can also you can also find the link to it in the meeting minutes. All right. So with that, let's conclude today's meeting. Thank you everyone for joining. We'll love to see. So we had a lot of users in the call today. So we're allowed to see more use cases, more ways you are using APISIX. Feel free to reach out to us and share how you are using APISIX, and you can also present it on the community calls. So this will help newcomers and people who are less familiar about APISIX learn more about APISIX. So definitely do that. So thanks again, everyone, and we'll see you next time, next month. So bye.
Yeah, thank you.